Hey guys, it's Mrs. Binford. I'm gonna go pretty fast. This is about my 5th time doing this, and James is probably tired of hearing me talk and using the same words over and over. So here we go. I want you to put at the top of your paper, Earth's revolution around the sun. We're going to start out with the sun in the center. Sun. Now I'm going to add the Earth in 4 different positions. 1, 2, 3, 4. Please note that the sun is not scaled to the Earth. The sun, compared to the Earth, in reality is a lot bigger, but for the sake of getting it on one piece of paper, we are scaling the sun down. Next, we need to add an axis to each of these globes. That is the imaginary line that goes right in the center of the Earth, coming out of the North and the South poles, and it is on that axis which the Earth spins or rotates. Next, we're going to add an equator. The equator is the imaginary invisible belt that goes around the Earth that divides the Earth into 2 halves. The northern half, the northern hemisphere, and the southern half, the southern hemisphere. I'd like you to use 2 different colors for each hemisphere. I'm going to use red for one, and I'm going to use red for the northern hemisphere. I'm going to color in the top half for all 4 of the Earth's positions. And I'm going to label those NH, 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 NH for northern hemisphere. I'm going to use a different color for the southern hemisphere. I'm going to color it in with green. You can use whatever color you like as long as it's different from the northern hemisphere. And I'm going to label SH, 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 southern hemisphere. Next, we're going to add arrows to our model, showing that the Earth is revolving around the sun in a counterclockwise direction. That means the opposite way that a clock moves. A clock would go this way, the Earth revolves this way around the sun. From one position to the next, so 1 arrow away, is approximately 3 months. 3 months. 3 months. 3 months. If we add all those together, what do we get? 12. 12 months in 1 year. So from start all the way back again is 12 months, the equivalent of 1 year. Next, we're going to add our seasons. I'm going to switch colors again so that we can keep up with the northern hemisphere versus the southern hemisphere. Let's start with the winter for northern hemisphere. I know that this is winter for the northern hemisphere because the axis is tilted away from the sun. The axis that we drew, which is it tilts the Earth at about 23.5 degrees. It would be straight up and down, but the axis shows us that the Earth is actually tilted. And in this case, the northern hemisphere is tilting away from the sun. So it's not going to get as much sunlight, so it's in winter. If we fast forward 3 months later, the season that comes after winter is spring. 3 months later, it is summer. 3 months later, it is fall, also known as autumn. Now let's do the southern hemisphere, which is actually pretty easy because it's exactly the opposite. Whatever is on the other side is what is going to be happening in the opposite hemisphere. For example, when it is winter for us, and we are in the United States in the northern hemisphere, in the southern hemisphere, in Brazil and South Africa and Australia, it is summer. We know this because their axis in the South Pole is tilted toward the sun, so they're getting more sunlight. When it's spring for us, it is fall for them. When it is summer for us, it is winter in the southern hemisphere. And last but not least, when it is fall for us, it is spring for them. It all works in opposites. If you know the order of the seasons, then you can very easily figure out the pattern that goes on this model. We're going to add a few more things. In the winter and in the summer, we call this the solstice. We call it the solstice, sol meaning sun, because in the winter and the summer, we either have a lot of sun or very little sun. Solstice, winter and summer. But in the spring and the fall, we get what's called the equinox. Equa meaning equal, nox meaning night, so we get the same number of hours of nighttime and daytime, about 12 and 12. And this cycle happens repeatedly. So as we go through the year, we have solstice, equinox, solstice, equinox, solstice, equinox, solstice, equinox, etc. for eternity. Last thing we need to add, where you have space off to the side, please write that 1 full revolution equals 3, 6, 9, 12 months. Which is also said as 1 year. And specifically, that is 365 1/4 days. So for the Earth to revolve around the sun one time, it takes 12 months, which is equal to 1 year, which is equal to 365 1/4 days. And that's it.